of information from the different files that we have. So I'm going to share my screen. We are going to have a recap and what is very important for us to all know and to understand. So let me share my screen here. All right. Can you confirm if you can see my screen? The PowerPoint presentation. Okay. So I see confirmation that the screen can be seen. So yesterday, we'll take 1 or 2 minutes to bring ourselves up to speed so that we can continue. Yesterday, we introduced the concept of data management for research and institutional decision making. We saw the tools that we are going to use throughout the different sessions, and we were able to install R and R Studio because that is what we are using for exploring, managing our data. Now, one important thing, again, is that when we are using R and R Studio, you open R Studio. You open R Studio, and when you open R Studio, you will definitely access R as well. And the other thing is, please be sure that you can access the Google Drive because the Google Drive contains information that we all need that we are going to use in this particular session as well. And lastly, just an update that I have updated the script on the Google Drive. So please, if you can access the Google Drive, download the script for today as well. It is just a build up from yesterday's script. And I'm just going to show us a bit what that looks like. So yesterday we had this script here in your Google Drive, day 1 data management.r. Okay, so we added onto the script and we have a new script, day 1 _ day 2 data management.r. Download this script here and put it on your data management folder, which should be on your desktop as we did yesterday. So it's very important that you have it downloaded there. We shall use it, but we shall also use the same codes that we started looking at yesterday. So back to our PowerPoint. Yesterday, we managed to install R and import data into R. So I am going to skip and go exactly where we stopped. And that was importing data into R. Okay, so, and also just to say that please continue to type in the chat if you have questions as we go along, but we shall surely pause when we are looking at the practicals. Data importation in R is an important step that we saw yesterday. And in summary, for all of us who might have forgotten, you can import files that are of a CSV format, Excel format, Stata format, SAS, SPSS, text, even from the web. You can import all that data into R. We demonstrated that yesterday. Maybe we shall demonstrate again if you don't have your data. And so when you import your data, it is important that you can check the structure of your data. And checking the structure of your data is the first step in understanding how your data has been imported. It is the first step in understanding how your data looks like so that you can start managing, preparing that data that you have imported for analysis. So there are few things that you do during inspection of your data, which includes viewing the data set when you have imported it. Yesterday, we saw how you can view by just clicking on the name of the data set, and you're able to see a snapshot. You can browse through the entire data set so that you can see how the information looks like. It helps you get that understanding. And then you can also check the general structure of the data, meaning you can see the structure of the variables within that data set to make sure that variables that you expect to be numerical, for example, are being captured as numerical variables. How many levels are there? Are they captured as they seem to appear, for example, in the metadata? In our case, our metadata we saw yesterday was in form of a data dictionary. Do you see that the variables have the same levels that were originally collected? Or do you see that some are missing? Data can disappear, by the way, when you are extracting it from different places. There can be mistakes, so it's important that you get a clear structure of the information that you have. You can also look at quickly the dimensions of the data that you have. You can view snapshots of the data. You can view the first few rows. You can view the last rows of your data. It's important that when you have your data, you do all these things. So because we are now practically doing things, we are going to go to R. We make our demonstration to show exactly what we are talking about. And then after, we give ourselves 1 or 2 minutes to do the same. And then we see what you do when you have inspected the data and you clearly understand the kind of information that has been imported into R. Remember yesterday I said just because you have the data on the desktop doesn't mean that it has been imported into the R workspace. If you must use R to manipulate data, to manage data, to analyze and visualize, you must make sure that you successfully import data within the R environment. So I am going to R now, and my environment is empty. My environment is empty. Yours probably already has the data that we imported yesterday. So every time you open your R session, I repeat, every time you open your R session, it's important that you load the libraries, not install the packages. These packages were already installed, and I said you install them once, unless you're going to uninstall R from your machine. So if you already installed packages yesterday or at whatever time, you don't need to install them again. What you need is to load the library whenever you are going to start your R session, so that the functions that are contained within the libraries can be loaded and ready for use. If you don't load libraries that are needed, your functions will not run. They will not be executed because R will not be able to locate them. So we are going to load all the libraries at once. So these are not the only libraries, by the way, that exist in R. There are many, and different libraries do different things. We shall see when you're analyzing different types of data, you may need different types of libraries, and you will add them here and load them accordingly. So, but in our case, this is what we need. So you can highlight all of them and run, and they will load. Okay, so mine are done. And yesterday we said, if you don't see the red button here, it means whatever you are running has been executed. As to whether it is successful or not, you check if there are error messages here. We don't see error messages, so we are good to go. And also, just to say again that the hash symbol is used to comment to help us understand what the code or the script is doing. Okay, so we are going to start by reading the data into the environment so that we can see our data here. So we have our data inside the data management folder on the desktop. And when we created a project, our working directory goes direct to that folder. So I am going to import the data using the import script. Yesterday, we also emphasized that the functions that import data depend on the type of file that you are importing. Okay, so CSV files are imported with the read underscore CSV, text files with table function, Excel files with read underscore Excel. So in order to run these, which I can run at once, but I will do one by one, we are going to import the data if you don't have your data. So you run. And we said once you're successful, you should see the object here that contains the name of the data that you have just imported. Okay, so that's the first one. So we import the second one. Then we import the third one. Okay, so you will see them appearing if you don't have them. If you already did yesterday, you just give us a minute so we can import all our data sets into the R workspace. Note that these are different types of files that are being imported, all transformed into R, and you can have all of them. We can import a SAS file seamlessly into R, okay? We also have the animal data. We can import it. So we also have it. So once again, the advantage we have with R is that we can have as many data sets as we want to put here. Of course, given your memory, but for now, we have all these data sets that we can use whenever we want to use them. You can reference them whenever you want to reference them. And we are going to see how to do that. You can also run, on your side, you can also run the data from the web. You can read information that comes from the web. If you have the URL that links to that particular document, you can click there and you will be able to import that data. This is a very large data set, actually. It has quite a number of observations. So maybe I can import this and see. Give it a moment so we can import that data frame until we see that this is successful. Remember also that the assignment operator is important because it's what helps you to store or give a name to an object that stores the information that you're bringing into R. Now, meanwhile, if you're getting information from the web, you should have stable internet. So successfully, I have imported data from this URL from the web into R. It's here. It has over 2 million observations into the R workspace. So we have the data sets that we need. I mean, you can add others, you can remove others. Yesterday, we saw how you can remove a data set from your workspace if you don't want to see it there. So today, we start off, if you have your data. Are there those who don't have the data? So in our case, we are going to use, mostly we are going to use the animal data and the Kisumu main vendor data. These ones is just to show you that you can import data from different sections. Now, if you're failing to import data, please make sure that the libraries were loaded. And if your library is not loading, make sure that that package was installed initially for you to be able to load that library. So people, if you have imported the animal data in particular and Kisumu main vendor data, then we can continue to inspect this kind of data. So now, we said that inspecting the structure of the data initially involves viewing the data, getting the structure of the data. Today, you're going to type within your frame here. You should be able to type in here inside your work space, you should be able to type in. So we are going to proceed and look at various functions that help us to perform these duties. We start with the view function. The view function helps us to view these data sets here. You can either use the view function or you can just click on the data set and still view it. So if I, for example, run view Kisumu 1, you should be able to view what is there inside that data set. If I want to view the animal data, I can do the same. Okay, so you can add codes in here. You can view the animal data. Usually when you start typing, it should prompt you to autocomplete the name of the data set. So you can view the animal data and run. Okay, it's the same task that is performed. You can always close that. You can also view the Kisumu main data. Now, as I do this, please do the same on your side. So we are seeing how the view function works. If your function is not working, please type that in the chat. Type that in the chat. So view at least 3 more data sets apart from Kisumu 1. Whatever you have in your environment, use the view function to view. If you have imported this DF, you can view it. If you have imported whichever data you have in your environment, try and use the view to actually view it. Okay. So I am able to view mine. And like we did yesterday, if you are viewing and you're able to do that, just type in the chat. Confirm. The data file that does not, someone is saying the data file does not exist in their working directory. Your data does not exist in the working directory because you did not put it there. And when you are working, make sure you can see the data underscore management up here, because this is the project that we are working with. This is the project we're working with. And when you go on your desktop, I'm going to quickly switch to my desktop here. Here in the desktop, make sure that you created your data management folder. And inside that folder, make sure that you have these data sets here, the Kisumu main vein data, the animal health data. Once they're inside this data underscore management folder, you should be able to import and access them in R. You should be able to access them in R. And I don't know if you can take a screenshot of what's going on. You can always just share it here and you get some help. All right, so it looks like we have been able to use the view function. We are now going to the next function, okay? And as I said, we have a little description of what it does. So str stands for structure. It helps you to view the structure of the data set that you have specified inside the function itself. So let's see the structure of the Kisumu main vendor data. So we shall pause maybe to take 1 or 2 questions. The structure. Okay, so when you view the structure, remember the output is down here, somewhere below here. Okay. So there are quite a number of variables. You can see that this dataset has the 319 variables. Okay. So some of them are numbers, others are characters. So generally, it shows you the types of variables that are in there, okay? Which one is captured as a character, which one is numerical. If, for example, you have certain categories, you can see them. We shall eventually see how to make them categorical, but now it's important that you can quickly see the structure of all the variables that exist in this particular data set. So that is the function or the importance of the structure function. You can do a structure of another data set. Since you have many data sets here, we can try the structure of the animal health data, this one. Okay, so so you can always check and see them there. Which ones are captured as numbers, which ones are strings or characters. That is basically what the structure function is helping you to do. So once again, please check the structure of maybe Kisumu 1 as well. Just continue typing within your continue adding code, especially under a given section, so you can be able to see that even your own code works. All right, so still under inspection of the data, there is a function called the head function that takes a snapshot of the first few rows in the data frame, and the tail function that shows the last few, maybe 6 rows in your data set. So again, we can see what that produces when you run the head function on Kisumu main vendor data. You may not be able to view the results very well here, but you can see that it shows the first 6 observations, generally to show how and what they look like, okay? Now, these are the first 6. The tail one will show you, let me see. So I'm trying to remove the zoom. Okay, so the tail function, when we run it, we'll see the last observations. So what I want you to do is to run your head function again on another data set to see if it works. Okay, so here we're looking at the head of Kisumu main vendor data, the first 6. Now I would like you to look at the head of the animal data itself, since we are going to use these 2 data sets interchangeably. You can click on the name if you are prompted to do so, so you don't have to keep typing everything. Okay, and you can always view results here. It usually brings the first 6 observations. And I'm going to pause here just to see if your head function is working. If your structure function worked, use the chart. Use the chart to verify. Use the chart to verify. Please continue confirming. Continue confirming. Continue confirming. And okay, so we have somebody saying animal data not found. Samuel, if your animal data is not found, it means you didn't import it here. Here. If you do not see your animal data here, it means you did not successfully import it. And so that means you need to go back here in the importing. Where is the code that imports the animal data? It's right here. Okay? The code that imports animal data is here. If you don't have animal data in this environment, you need to run this line here. Okay? So that you can see the data in your environment. You cannot now view or get a structure of animal data if you have not imported animal data into the environment. And I also saw a comment in the chat. So somebody is saying it is imported in the environment, but the object animal data is not found. Yes, it is not found because animal underscore data has a capital D in the environment, and what you have put in the quote here has a small d. Now, R is case sensitive, so it will not locate this data set because it doesn't exist. The one that exists has a capital D, animal underscore capital D. So what you need to do, you need to make that D capital so that you can import the data successfully, or you can run the structure successfully. Pay attention to the spellings of the names of those data sets here. The one that starts with a small d will not be read because it doesn't exist here. Somebody is saying, kindly share for us the R dictionary. I have given it to you. I have given it to you unless you have failing to access it on the Google Drive. But if you access the Google Drive, like we did yesterday, we have this script here, and I believe it is the script that we are all using now. I believe that it is the script we are all using now. All right, somebody says there are can't import data and it is in the data management folder. Is it possible for you to take a screenshot of the error? Because we need to see, did you load the library? If you're having a problem importing the DF data, probably a connection to your web, you can do that much later. You can do that much later. Somebody says, is the animal data the same? Yes, it is the same. But what happens is when you import it, we give it a name, animal underscore data. Okay. Steven, somebody's asking for the link to the Google Drive. Can you please paste it there as we proceed, especially for those who joined today? Okay.
Is it on WhatsApp or on Q&A?
The chat, it's on the chat. I am reading the comments from the chat.
Okay, I'm doing both. So yeah, I just posted.
All right. Okay, so if you don't have access to the Google link, please look at the link there. So now we have run the view function, use the data sets that you have imported, okay, into the workspace. You cannot run data that doesn't exist here. So the data that you're seeing here is what you're going to use. So we have checked the structure of the data. We have checked the structure of Kisumu main data, of animal data, just to see that that code works. We also ran the head function on both the Kisumu data and the animal data. We have run the tail function. This one just shows a snapshot of the last values. Okay. Now, why sometimes you need to see the last values, because some of these observations are many and you might not be able to see them. You might not be able to see them, so you can take a snapshot. Now, that is what we did, and that is what we paused to do. So again, I asked in the chat, confirm. Challenge with the Stata online data. You see, if you are dealing with, if you want to import Stata data, make sure that you have loaded this library here, especially having this one. Loading the library means running the line that has the word library. So make sure that this was run. If you don't run this line properly and successfully, you will not have those functions that bring the Stata file, the SAS file, the SPSS file. That is the other reason why people are failing to import maybe those files in particular. So do not start working if you have not run the libraries, because some functions will not work. And our interest is to see how we can look at the data, which is what you're doing here. Now, the other function that I will go through, so I'll go through two functions and then pause for you to do the same thing. The other function is the DIM function for dimension. And what does this do? It shows the number of rows and the number of columns. So the dimension function does the same thing as what you see here. For example, the Kisumu main dataset in the environment has 2,927 observations and 319 variables. So remember, these are the number of rows, okay? And these are the number of columns. So the dimension function does the same thing. So if we run this line here, 59, okay? We see the dimensions here down in the console here. We can see the first one is the number of rows, which is the number of observations. The second one is the number of columns, which is the number of variables. So generally, this is what the dimension does. It shows the observations here and the number of variables here. Okay, so I would like you to check the dimensions of the animal data if you have imported it. Maybe Kisumu 1 data if you have imported it. So we are going to use the dimension function. So the dimension of animal data. And then we run. Okay. When you run that, you have 1,480 rows, 146 columns, which is the same here. It's the same, the number of observations and the number of variables, which translates to how many columns exist in this data set here. Okay? All right, so I will pause so that you check the dimension of any data that you're seeing in your environment, any data that you're seeing in your environment. And we are pausing to know if you have been able to run the dimension, just to see the number of variables and the number of observations. So, okay, when you're done, please type here, done, successful, yes. Somebody's saying their error says not Kisumu main vendor dataset, not found, that object. If your Kisumu main vendor data is not found, if that's the error you're getting, and for those who are getting that error, it means it is not here in the environment. You cannot see it in the environment, which means you did not import it inside R, okay? Because you can only perform the functions when the data was successfully imported. It is important that we have the data, that you can see your data here, okay? Somebody's also saying they could not find the function view. You typed view with a small v. The function view has a capital V. So please change the small v to the capital V. Okay, so the person whose data is not being found here, import that data, okay? Import that data. Either you come back here, look for the code. I assume you're using the script. Look for the code that imported Kisumu main data. It is this one here, this particular one here, the very first on this line 20, where there is Kisumu main vendor. This line here needs to be run so that you can see the data in the environment. If you don't see it, you will not perform any function on a non-existent data set. So try and do that and let us know if you have successfully imported it. Try and do that. If you fail, then you can come here and click on this, and we shall import it from here, just like we did yesterday. If you're failing to run the code, you can also do the importation from here, like we demonstrated yesterday. So continue letting me know if okay. Kisumu main data not found. It is in the environment. Do you see it in this environment here? If it is there, then we should be able to have it. Okay, so the DF data, if your DF data is not loading, it's an internet issue, and also it needs a lot of space. So please leave it alone because we are really not going to be using it now. The naming in the environment should match with the naming in the script. Yes, that is true. Okay, so I have confirmation that the dimension function worked for quite a number of hours. So now let's look at the names function and what it does. Okay, so the names function just produces the names of the columns that exist in the data set. So when I run that, it gave the names of all the columns that exist in the Kisumu dataset, and there are quite many. So the first one being start time, then end time, survey date. So you quickly can look at the names of the variables that exist within the Kisumu main vendor dataset. You can also check for the names of another data frame here, like the animal data. You can also check for the names of another data set, like the animal data. Run that and see. Okay, that also works. I have quite a number. I could choose Kisumu 1, 2, 3, 4. So I will demonstrate just 1 or 2 and then let you do the same so that we can see if you are able to run the names data set to be able to check out the names of the variables. So we give ourselves a minute for you to confirm whether the names is working, whether the names is working. Okay. Somebody raised their hand. Keita, can you type for now? We shall maybe be able to open that up later when we are in a break. Couldn't find the function name. The function is not name. The function is names with an S. So make sure that here you have put names, not name. Okay. The function should be names. Somebody says they are trying to read the CSV and it's not working. The person that is saying they could not find the function read underscore CSV, please pay attention. The function cannot be found because, let's go back and I show you, because you have not loaded or called the library of tidyverse. Remember I said before you start working, make sure you highlight and run all the libraries. So the function read underscore CSV will not work if the library of tidyverse is not run. So it means you have to click on tidyverse and run the library of tidyverse. And then after you come and run the line that imports the Kisumu data. Okay? Then you should not be having any more issues. So please try that out. The reason why they cannot find that function is because you have not run the line that has library tidyverse. Run it, then import that data. Run it and import the data. And okay, as we proceed, somebody wants to load the DF function. You can import it, but you need very stable internet. If it's not working now, let's proceed. Okay, somebody has got another error here. No, that's not an error. That's just a warning. Installation of R. Right now, we might not be able to install R, but what you'll do in the Google Drive, there is a link on how to install R, and you will just find a link, click there, and download it. It should run very fast, actually, for you. Okay. All right, so now there is no package called tidyverse. Okay, the package is not there because you didn't install it. So again, you must install. The code that installs is right here. It's the first one, install packages. So run this code. I'm not going to run it again because I've already installed. Run the code. Yesterday we ran all these installations. So I want to believe that if you followed through, you do the same. If you didn't, then install by running this each line. And when you install, then you can load the library. That will work for you very well. Okay, so that is great. We have been able to obtain the names and also be careful on how you spell the function. If it is names, let it be names. If you say name, it will not find that function. Okay, so these functions that we've seen, these groups of functions, the names, the dimension, the tail, the head, the structure, we can clearly see that they help us to see and have a snapshot of the data that we are dealing with. That is important because in your mind, you are comfortable that the data that you're dealing with is something you understand, is something you can navigate, is something that you can see. After that, what else do you need to pay attention to? You need to pay attention to the fact that can you manipulate the data? Can you extract the things that you want from the data? If there are certain rows that are important to you, can you create a data set, okay, basing on certain conditions? For example, can you extract only data from male vendors? Can you extract data from a certain word, a certain slum? How can you do that? You need to know and understand how to use the functions that have been designed to do that very easily, okay? So we are going to look at how to create subsets, how to make changes, how to manipulate data using various functions. We shall do them one by one so that in the future, when you want to perform one of them, you know the function that can do that for a new data set, because you are working in different fields. You probably have different data sets. How can you do the same with your data set if you have been told now import your own data and get the structure and extract a certain value from it? So that's what we're going to look at. And the first function we are going to look at is the filter function. You see this filter function here? This filter function helps us to extract rows, okay, basing on certain conditions that we want. For example, you might want to extract information from only females, information from only males, information from only a certain region. So generally, the filter function will help you to do that quite easily. And how does the filter function work? The filter function requires you to specify the name of the data. And why does it do that? Because in R, you have many data sets, and it cannot detect the one you want to use unless you specify the name of that data set. Okay, you can have 20 of them here. So which one do you think R will use? You must give the name of what you are interested in. So that is where you place the name of the data set and the condition that you want to use to, for example, generate or extract the data. So we are going to look at a simple example. And in that simple example, we are going to look at the slums that are in this data set, first of all, before we run this particular one. What does this code do? In this code here, remember we said you have to create a new, if you want, for example, to extract only those that are from a certain slum, then you give it a new name. This name here doesn't really matter. You can change it. You can call it Obunga. You can, like, it is a name that I gave because that's what I wanted. You can change it. You can give it another name. You can give it a shorter name. It doesn't matter. And the assignment operator means that it will filter from the Kisumu main vendor where the slum is, Obunga. That is the data that will come. So when you first of all go to the Kisumu main data here, there is a variable that contains the slum, okay? So there are different slums here, and we have one called the Obunga slum. We shall see how to sort of view them all. So when I run the filter line, okay, by specifying that the slum should be Obunga, we should be able to see the outcome. So when we run, that is successful. So for starters, I want you to note that Obunga slum data now will contain only information from Obunga slum. That's one. And you see that the number of observations is much less than that of the Kisumu main vendor dataset. It means it has only picked information that comes from Obunga. And if you want to see how that looks like, you can click on Obunga here so that when you come to the slum, you can confirm that you are only seeing Obunga slum, okay? You can try to scroll down. Usually when you see your information, makes it easy. So you can see that we've made a selection for only Obunga slum. That was successful. When I usually open my data sets, I close them just so I don't have so many things up here to look at. So that is what this does. That is what this does. Now, we can also do another filter. So I did that just to show you that it works. You can also run the same, check it works. We shall pause to confirm. I did another filter for the male gender only because inside the Kisumu main data, there is a variable that captures the gender, okay? We have female vendors, multiple females. We have male vendors. We even have both male and female. But in any case, I was just interested in the male, okay? And I may ask you to find out how many are female as well in this data set. So again, I gave it a name, male, out of my own will, and I filter from the Kisumu main when the gender is male. Again, we run, okay? And we have the male data set created. This male data set here contains 397 observations, and that means you have 397 males, and all the males appear in the same file. Now, someone may ask me, why are you creating subsets? Because it is important that you do not destroy or overwrite the main data set that contains all the information, okay? If you want to extract, then extract it and put it elsewhere, but leave the main data set alone because you do not want to really change the original data. So if you look at the male data, you can quickly confirm that now you only have the male gender, that you now only have the male gender. So I'm going to pause here. I'm going to pause here, right there. I'm pausing because I want you to run and filter the slum data, okay? And the male data first, and tell me whether that is successful. Then I'm going to give you a small assignment where you are going to change male to female so that we can see how many you get. So run this line that filters out those from Obunga slum, and also the one that filters out the males, the male vendors. And we pause for a minute to see if you're successful as I read the errors that are popping up. Error, object gender not found. Slum not found. Slum not found. Successful. Half-Tom and Ferry. If you're not finding the slum, I'd like to know if you are seeing the Kisumu main vendor data on your environment. Somebody is asking me to share the original file. The original file is in the Google folder. Please download it from there. Okay, download it from there. Download it from there. Okay, download it from there. If you've done for females, you can also put answers here. So if you're seeing the Kisumu main vendor data, the file is there in my environment. Okay, that is good. So if the file is there, then we should be able to see the slum. Okay. Okay. I don't know if it is possible for somebody here to take a screenshot, especially if you are failing to get gender. Now, I want to do one thing, and Christella, if you can hear me, or somebody who is failing to get gender or the slum, if your error is saying it is still not found, then I want you to raise your hand. I want you to be able to share your screen so I can address using one person's screen. Okay, so now that is what we want to address. So I'm going to stop sharing my screen. And I'm doing this because I want us to be on the same page. And let me see. Okay, so now I want to allow, I don't know, I have chosen alpha. If you can hear me, you can unmute yourself. Or also, if you can hear me, you can unmute yourself. I don't think Alpha is hearing me. Maybe. Let me get somebody else. Edna, if you can hear me, you can unmute yourself.
Hello, please.
Hello, how are you?
I'm okay.
Do you have the same challenge?
It has finally worked.
It has finally worked.
Yeah.
Oh, okay. All right, thanks. So
Please, maybe let her share her screen and maybe show how she solve a problem. Maybe that might help.
okay. So Edna,
Yes.
can you share your screen?
Okay.
Are you able to share your screen?
I'm trying. I'm looking for the feature here that supports it. Then.
Okay. Okay. Let me see. It looks like you don't have permission to share your screen. You can't see it because you don't have permission to share your screen.
But what I did, I had to run again the library. The other things worked here, but when I refreshed and ran the library and I went back to filters, it worked automatically.
All right. So thank you, Edna. So what Edna is saying is the reason why your filter is not working is because you didn't run the library of tidyverse. Tidyverse is the library that contains the filter functions and all the other functions. So that tidyverse is very important. So please run the library of tidyverse so that you can be able to filter. Okay. So somebody says they can see 2371 observations. Yes, you are on the right track. So, let me go back. Now I'm sharing my screen again because now what Edna explained is that the filter function, this line, will not work if you have not loaded the library of tidyverse. This library is very important. It's the one that has most of these functions that we're now looking at. So if that is successful, then it will work. My assignment for you now is to create a data set that filters the females. So when you go to the Sumo main data, you should see the female gender there. This one here, female with capital F. So if you're going to run that assignment, okay, I like to just copy and change a few things here. And I start with making this the female data set so it doesn't confuse anyone. And the gender in particular has to be female. That is what we want to have. Okay, so if you run this data set, this one here, if you run the filter on this, it will filter the female gender only, and it will give you the number of observations here and the number of, and I don't want to run that. I want you to be able to run it and type the number of observations in the chat. Okay, run the filter on female, type the number of observations you're seeing in the chat. Okay. All right. That is correct. So we are having the same. Okay. Please continue typing. You might come up with a different number and we may need to verify why. Okay, so the number of females seems to be consistent. Somebody has 2281 Wesonga. Now we need to know which females you extracted from the main vendor data set. Okay, okay. All right, so I see we have 2371 females, which is correct, which is perfect. Great. So we are able to do this very well. So let's look at a new filter. Now, right now, you were able to get how many are from this slum, how many males are there, how many females are there. You can also have more than one criteria, okay? For example, you might want to know how many vendors come from Obunga and they are male. Or better still, how many male vendors come from Obunga? Something like that. So what does that mean? It means that, I mean, I gave it a new name, Obunga male. You can also give it. So it means that you have to specify both conditions. And the first condition is that the slum is Obunga and the gender is male. Okay? It's important that you put the right criteria that you are looking for in the filter function. So we are going to run and see what result do we get. Okay. I'm now looking for Obunga male. So you need to look for the right object here. It's right here. So there are only 60 observations that fall in this criteria, meaning we have only 60 males in this entire data set that come from Obunga, And if you click in the Obunga male data, and you go to the slum, you see that the slum, if you do this, you see that the slum is Obunga, but also the gender is male. Okay? Because that's the criteria you put, and those are the ones that you want to see. So, you're going to do the same. Now, I want you to find out how many females are from Ubunga. How many females are from Ubunga? So, as I said earlier, retyping may take longer, so you can always copy and make sure that these are females, because you want to, if you don't differentiate the names, it will override the existing data set, which I probably don't want to do. So Obunga female. The criteria is the slum is Obunga, so we are going to leave it like that. And the gender is female because we want females from Obunga. So the issue is how many are they? And I'm not going to run it now. Please run it. If you're successful, type the number. Now that will help me to understand if you are running it correctly. Okay? How many observations are you seeing in the Obunga female data? Female vendors from Obunga. How many are they? And we'll pause so that we proceed. Somebody has 0. Slum not found. Is there a way you can take a screenshot of what is happening on your desktop and just send it and attach it? It will help me a lot to see what's going on your side. So filter is not working. Okay. Did you run the tidyverse? Is tidyverse loading, first of all? Meanwhile, somebody has 0 females. That is not possible. It's not possible that you're going to have 0 females. Oh, somebody saying you may have written female with a small f. Yes, please check. Check if you have written female with a small f. It may give you 0 because it's not finding it. Okay. Please, Alfred Ferry is asking, how did we load Slum? Slum is not in the environment. No, Slum is not in the environment. Slum is a variable inside the Kisumu main vendor data. So if you can see my cursor, it means you must load Kisumu main data in the environment, and inside, when you click on it like this, then you can scroll. You can scroll and find the slum variable. You can scroll and find the slum variable. Okay, so to answer your question, what you need is to make sure that you have the Kisumu main vendor data in the environment. The slum should not appear here because the slum is inside the main vendor data. And let me see here. I see that we have the correct number here, 408. Okay, so somebody is now working well. Okay, if you want to install tidyverse, go and click on the line that says install.packages tidyverse. Crispin, you cannot load tidyverse if you have not installed it successfully. I got 408. That is correct. That is very correct. So I see that we are succeeding. We have 408 observations. That is correct. Okay. That is great. Now, we are going to move. We are still filtering data. And you can, by the way, put any criteria here. We shall see maybe different words. Maybe we can change the word. We can see the slam. All right, let me give you one more practice because it's better you practice now so we can see if you're really doing the right thing. So Kisumu main vendor data has it has a word. No. It has these ones here, multiple females. Okay? We want to know how many multiple females come from Obunga as well. So come back here and put multiple females in there. I mean, I'm just going to get a new line because I don't want to change. Now I'm going to just say female 1 because I don't want to change the name of that thing. Then I say multiple females here because that's what we want. And that female has a small f according to what I saw there. So we want to know how many businesses or are owned by multiple females there in Obunga. Run this for multiple females. Please, once again, you don't have to really retype this entire statement. You can just copy that statement and change the criteria. Find out how many they are and let me know in the chat. Somebody's asking, where can I get Tidyverse? There is, in this, there is an installation for Tidyverse right here. Scroll up in your, scroll up here, and there's a library. If you didn't install it, there's also an installation. You run the installation, click run, then you come down. When it's successful, you come down to library, then run it also. And there we go. Then you come and we continue working. So meanwhile, we are here. We are finding out how many multiple females own businesses in Obunga, those vendors there. So you will see if you use the same name, female 1, then that's the data set that we're looking for. Please run and give me the number of observations, then we can proceed. We are giving ourselves a minute. Please don't get frustrated. Continue to let us know of the challenges that you're facing. Somebody has 0. 0 is not correct. 0, the reason why you have 0 is most likely you didn't spell the multiple females very well. Okay? Somebody said females. Give us the number. 0 is not correct. 12 is correct. If you have 0, kindly look at the screen. If you have 0, make sure that you have specified multiple female like this with a small f, with a capital M, with the space. If you don't, it will not find that group because that is how it has been captured in the Kisumu main vendor data. Now run that when you have exactly what you're seeing, and then continue to give us the number. Okay. Somebody still has 0. Pristine, you're saying your Tidyverse is not working. Tidyverse, you need to install. If Tidyverse is not working, it's because you haven't installed it. Because you haven't installed it. Okay, let's see the errors that you're seeing. Somebody's getting 83 observations. How do I install R tools? Okay, I'm trying to read the comments, and they are kind of moving very fast. But now the conflict is okay. There's nothing wrong with the conflict. Okay, so let's look at the Kisumu main data again. And oh, this is multiple females. Okay, so you can add the females with an S here and run. Let me put up the whole line so you can see. Meanwhile, you should be having this script, and so work in your script. Don't create a new one. It will take you longer to try and type. It will take you much longer. So somebody has 12 now. Okay. Okay. Looks like we are now seeing 12, 11, 0. 0 is not correct. 12 is correct. Don't forget the S like I did. 11, 12. Okay. So looks like we are getting the right answers right there. And now we are going to continue filtering, and we are filtering now using the criteria that involves a numerical variable. See, these are categories. You can also filter using numerical variables. So we are going to look at this example here. In the animal data, I will open it first to explain. There is a variable called age, this one here. Age is a numerical variable, but we can also use it to filter. For example, you can choose animals that are aged 4, maybe 4 weeks, 4 months, whatever it is. You can choose those that are aged below 8, below whatever criteria we want to use, we can use it. So we are going to start with a simple criteria. From the animal data, okay? Again, remember you need to specify the name of the data set because there are many. If you don't, it will not know which one to use. So we are going to filter out those of age less than 12 and store them in a data frame called data. And we want to know how many of those animals are there. Maybe that's the analysis you want to perform. And how do you extract that data? So we're going to run. And when we run, when you're wondering what is the name of the data set you've created, it is here. Look at it here. It is what you specified at the beginning. It is the name of the data that has been created. It is called data, so it's right here. We have 1,331 that are aged below 12, that are aged below 12. This is perfect. Run this line. Let me know when you're successful by typing yes, done, just to know if you are successful in running this filter. And let me know of the challenges as well. Okay. Looks successful. Looks successful. Looks like we are doing the right thing. Okay. Yes. Okay, so we are Okay, somebody's saying getting select rows where the animal age is less than 12. Yes, that is what it does. Okay, now we're going to do only one exercise. For example, let's find out how many animals, because this is animal data, how many animals are aged beyond 10? I don't know, 10 weeks, 10 months. So we want to change this criteria to maybe above 10 months or years. So remember, we can copy and I don't know, I'm going to say maybe new data. I'm just giving names. You can name this thing anything. And we can change the filter to greater than, you know? So you can say equals to, you can say greater than, you can say less, you can do any, 10. We want to see them, but I'll not run this. I want you to run and tell me the number of animals above that age. The number of animals above that age. I continue to say tidyverse is very important because the functions that we are using are in tidyverse. Okay. And please use the chat to find out how many animals are aged above 10. I'm seeing answers 149. And we seem to be consistent. Somebody has 83. Okay. 19. Okay. 149. So let me run. How did I add new data? Oh, just copy and type there. Meanwhile, please, you can type inside the script. Continue typing inside your script. The script is yours. So you can add, you can document. It will not change. If you're getting a different number, just type it there. Why am I getting a different number? Make sure you are putting the same criteria that we are having. So let me run this new data. The script ran, but I cannot get the result. The result should, if I run new script, okay, let me run this thing now that I see that we are successful. When I run it, new data is here. If you cannot see it and it has successfully run, scroll down on your environment. Sometimes it's hidden down or up, depending on where it is. Please scroll so you can find the data. So as they become many, you will have this bar that helps you to scroll through to find the name of the data that you have just created. Okay, so it's 149. We should be having 149 animals greater, okay, aged above 10. Okay, great. That seems to be working for all of us. Another thing that you can do, okay, apart from selecting these rows, you can always practice on different criteria. Another thing you can do is to sort the data, especially if you're dealing with a numerical variable. So the function that helps us to do that is the arrange function. What does the arrange function do? It sorts data in either ascending order or descending order. And how do you use the function? The function is arrange, but you need to specify the data frame once again and the variable for which you want to arrange. So right now, if we look at the animal data, again, you scroll if you can't see it. If you look at the animal data, for example, now we see the age, right? It's in no particular order. So we can arrange so that the age is arranged in either ascending or descending order. And when it arranges the age, it comes with every other row, information on that row. So it arranges the rows, okay, basing on the age. And sometimes it's important that we do that for some analysis, but also to see your information. So we are going to arrange the age in ascending order first, and then arrange it in descending order by putting the negative sign there. So we start with ascending order, and it's data 1, this one here. Okay, that's the name of the data set. So data 1, you can confirm by looking there to see that the age has been arranged in ascending order. You can go down and see. So we can clearly see that the age has been arranged in ascending order. That's great. You may want to actually rearrange this age in the original data. If you want to do these things in the original data, then what you do is to put the original data name here, which is something I really don't want to do now. I don't want to change the original data. Or you can arrange the age in descending order by putting this negative sign on the edge with the arrange function and run. So data 2 should have age arranged in descending order. So that's what the arrange function does. Can I pause so that you can run the arrange function? Arrange age in ascending order, then arrange age in descending order. Let me know if they both work by typing yes, completed, done, successful. Somebody is not on WhatsApp. The link to WhatsApp, somebody can help you put it there. Right now, I don't have it nearby. Could not find the function arrange. The function arrange will not work if tidyverse is not loaded. Someone is asking what's the importance of the double. Can somebody just edit the script? Yes, you can just edit the script. You can just edit the script if you want to. Somebody says they cannot access the dataset. Datasets are on the Google Drive. You download them, and then if you missed yesterday's class, you can look through the slides and the YouTube link that was sent. It will clearly state how you download them. Okay, so okay. Somebody's asking when are the videos, presentations going to be sent? They are sent. The ones of yesterday were already uploaded on the Google Drive. So we send them when we are done with the presentations. I see that people are getting done. People have been able to arrange. And when you say done, I assume it is both ascending and descending order. Okay, so why did we put the bracket? Oh, yes. So we're putting this because we've added the negative sign there. You can try to run without that double bracket and see if it works. Okay, somebody's saying, how do I filter data between a certain range? You have two criteria, age less than 10 and age greater than. Maybe if you want between, for example, 9 and 11, it is age greater than less than 10. Okay, and age greater than 11, so that it is in the middle. Okay, the range is correct. So your and can be on the same variable if you want a range of variables or a range of a certain variable that is numerical, like this age here. Okay, once again, it looks like that is working. Now we are proceeding. Something else that we do is sometimes we select certain columns, especially when we are preparing. When we go to the data science module in the other week, you will see that the data sets are large and you need to select certain columns only for analysis. So it's important, it's imperative that you can extract only the columns that you need. And you therefore need to know the name of the column so that you can extract only that column. So we are going to see, how do you extract the columns? Now I am moving like this because we do have these scripts and we can be able to run them and explain them. So the function that selects the columns is called the select function. Once again, you select and specify the name of the data frame. And this time round, because select is selecting certain frames, you put the names of the columns that you want. You list them and it will select them. Let's start with this one first. We're going to explain what this is doing. So data 3 will contain a selection from the animal data set. We shall select the age in weeks, and age in units. So what do we expect? We expect that when we run this, our data set should have only 3 variables because we've selected only the age in weeks, and age in units from the animal data. The original animal data has 146 variables. There are many, very many, okay? But if we want a few for whichever analysis, then we use the select function. We're going to run this. And it's data 3, okay? So data 3 is here. It has only 3 variables. That is expected. When you look at it, it has only the age in weeks, and age in units, because that's exactly what we want to have. Now, this is a random criteria. Of course, you might want to include the ID, then you would put it there. But the bottom line is, it is the select function that performs the function of selecting specific columns for data analysis. It is the select function that does that. Of course, we are going to pause to check if we are doing that right. We had forgotten about our Kisumu main vendor data, but we are going to select some columns from the Kisumu main vendor data set as well. And we are selecting consent because there's a variable of consent. We are selecting the county and the location type. We want to see if you are able to do that as well. So this is data 4. Remember, the names are here, okay? Don't get confused on what happened and where is that being stored. Look at the name that has been created. It is the name you gave to the object, which is data 4. So data 4 also has only 3 variables because that is what we selected. That is what we selected. We pause. We determine if select is working. We pause. We determine if select is working. We proceed. Yes, please. Done. Yes. Successful. Yes, you can even just type 1 for yes. So we are moving slowly, but now you will be able to understand the code. When we give you the entire code for analysis, you will be understanding the code and what the functions are doing. Okay. Okay. So that's great. So looks like people are successfully picking data. We are going to take a break after running through the select. And in that break, you will do a very small exercise. Now, you can also select all the columns except a column that you don't like. So if you want to deselect, you simply have to put the negative sign here. What does that mean? It means that if you put the negative sign, all the other variables will be selected except that one. Okay? So you see that in the Kisumu main data, we will demonstrate before we go there. In the Kisumu main data, this one here, there is sub-county, right? Okay, there is a sub-county data set. Now, I want to deselect it. It's more like I want to delete that column, okay? So what happens is you need to put the negative sign on the name so that you have a data set that doesn't contain that particular column. I mean, you could just want to right-click and delete, but unfortunately, that's not what we do. So we are going to create dataset 5 now. Dataset 5 should not contain sub-county when you scroll through, okay? Because you deselected it, and that is true. Sometimes you need to deselect some columns, especially when you're doing analysis. So it's important that you actually know how to remove them, okay? Since we are still in the selection, after this, we are going to take a break. And in that break, you'll do a very small exercise. Data 6, select. We are going to, you can also select columns that start with a certain letter, that end with a certain letter, that contain a certain letter in their name, if there are many and you want to only keep those. So we are going to select columns whose names start with S from the Kisumu main data. So the Kisumu main data, this one here, has many variables. But the criteria we want to take now is any variable that starts with letter S should remain in the data set. Okay? So how do we do that? In R, you can say starts with that letter, and you will have them, any letter. Sometimes we name them according to letters. And so we'll look at data 6. Data 6 here should have only columns that start with S. Only columns that start with S. The rest will be dropped. So we have quite a lot of things we can do. We might not exhaust them, but these are important that you know how to select columns. So our last pause before the break is to find out if you are able to deselect by removing a certain column, or if you're able to select columns that start with S. Run when you're successful for both. Somebody says that they're not completely deleted. They are deleted from the data. They are completely deleted, so you can't even see it at all. It doesn't hide them. That's why we are not overwriting the original data set, because if you overwrite the original data set, then we don't know. You have to re-import it. So we are not overwriting the original data set because deselecting deletes columns from the data set completely. All right, successful, done, 1 if you are succeeding. It's important that you give feedback if you're succeeding and even when you're not succeeding, so we can know what's going on in the background there. I want not to select column 2. Okay, okay, great. I see that we are successful. Okay, so we are going to take a break, and in this break, we are going to do a small exercise, which involves filtering anyway. So the exercise is activity 1. It's a very simple activity. We're going to do it together, but you need to do it and submit it on your own. And it's right here. So what I'll do, I will put it. Oops. Okay. And in the chat, for everyone, there is an activity there for you to click. So the activity is simply asking you to filter. Can we select 2 letters? Yeah, you can. Molly Nakajimo is saying She is not successful. She got lost from the slum and gender not found. Okay, we are going to Molly. Molly, you need to put up your hand. Put up your hand so that I can allow you to speak. And I'm going to allow you in a short while. Now, the rest of us, please click on the link that I have sent that contains the activity. If somebody already attempted, I think that is also okay. You can wait for the rest of us. The break is about 10 minutes. The break is about 10 minutes. Please, when you're done, you can submit. So let me look for Molly here. And I think I'm going to stop sharing and try and look for Molly. Okay, somebody's saying display the scripts. I'm going to display them. Let me first look for Molly here. Molly, is your hand up? Yes. Please unmute and speak. Hello.
Hello. Good afternoon, Doctor.
Good afternoon.
Yes, I have been following through and everything has been working until we reached the part of filtering rows.
Okay.
The first where we're filtering to get the slum called Obunga, it didn't
Okay.
work when I ran. Then you told us to make sure we run the libraries again, but I had
For
run them
tidyverse.
before. Yes, I repeated to run them again, but even after running them, it still showed me the same thing. The object slum is not found, plus gender not found, like continuously. And then also after that, I couldn't follow through other tasks like arranging. It could show the same thing, even selecting columns. So I don't know, but I continuously kept like rerunning the library for tidyverse.
But
Yeah.
is the library for tidyverse successful?
Yes, it is successful because I was able to do all the rest.
No. What do you mean the rest? The rest are not from tidyverse. The ones before are base R functions, so they don't need what do I say? They don't need tidyverse. Okay? So
Yes, Doctor.
tidyverse functions start from filtering. So arrange, filter, select, that's tidyverse.
Yes.
Now, I really don't know if you really succeeded. If you're failing to do tidyverse, okay? I'm going to share my screen now. Maybe because tidyverse is becoming a problem. If you're failing to use tidyverse, this is what you're going to do for me.
Yes.
Okay?
Yes.
I want you to install just one package, this one here. For those that are not having tidyverse, please follow together. Install. Go to your console and install .packages. Okay? Dplyr. This one here. Okay? This will install only one package called Dplyr, which is part of tidyverse, but maybe the challenge is with installing so many of them in tidyverse. Install the packages for Dplyr and then, okay, load the library for Dplyr because the specific functions we are dealing with are actually in Dplyr. So that is also Crispus and all those that are failing to use tidyverse. Okay. So install, I already have it. Just install this. Let me know and call the library of Dplyr. Then go back to filter. But also make sure you see the data on this side. Make sure you see the data on this side so that we can continue to access the correct data sets. If you don't see data here in your environment, means you cannot access it. Okay? So if you're failing to use tidyverse, then install dplyr, load the library of dplyr. Let
Please,
me know. Yes?
can you hear me? The first thing
Yeah.
they should do, they should go to their desktop and check from data management if they have the data. If not, let them go and download it from the Google Drive. Because
Yeah.
if they don't have the data in the data management folder, it's not going to be, yeah. So I think that's what they should do first. Thank you.
Yeah. If you don't have the data on in your folder, just go to the Google Drive and put it there. So somebody said they also installed dplyr and it worked. Yes, because dplyr has those particular functions. If tidyverse is not working, then use dplyr. It is only one package. Okay, somebody says it's now working. And if it's working, that means you can now run all the other codes that are available. And let me see. Okay. Please continue to install dplyr and confirm if it's not working for you, and the library of dplyr as well. Yes, when it tells you it has been masked, that's okay. There's nothing wrong with that's just a warning. And just yes, restart R. Just click on yes. Dplyr is not working as well. Okay, at some
Dplyr is
point
working for me, doctor. It's now working.
it's now working.
Yes,
Okay,
it is.
that's
Thank you.
okay. That's perfect. You may mute. You may mute. Okay, so install. I can't access the data on my drive. No, you should be able to have it. So if you have it in your folder, then you need to now do the importation of the data. Like we did yesterday. But if you have data in your folder, for example, I see somebody says they have it in their folder. To make your work easy, somebody says, where can I access dplyr? Dplyr, you type it, type that. Now I've just typed it here. If you can see my screen, just put there install.packages dplyr and go ahead. The person that doesn't have data and it's on your desktop, come here. You can come to import. If you are seeing my screen, you can come to import. And because the animal data and the Kisumu data are CSV files, click on text from read R. This is where you need to click. And then when you see this screen, you browse to your desktop and look for that data. For example, the Kisumu main data here. You main vendor data, then you open it, allow it to load here, and click on import. Then it will bring the data for you, and it should be here. All right, meanwhile, for the rest of us who are doing the small assignment, okay, it's now working. Well, that's great. So if they're saying R tools is required to build R packages, but is not installed, okay, this is what you need to do. You need to install that R tools. So what you do is you come here and install R tools using the install.packages. If that's the message they're giving you, then come here and put R tools in the brackets there the way it is and run it to install it, and the rest will work. My R Studio has been processing since, and Crispin, it's because it's probably a memory issue with your computer. I can't find on Google Drive. Which drive are you looking at? There is a link to the Google Drive for the class that has been shared. There is a link. to the Google Drive. Stephen, you can continue sharing the link to the Google Drive on the chat so that somebody can access it. Meanwhile, they are now starting to work. Thanks. Okay. Okay. Great. Somebody's saying Manyata has different 0 observations. Check if Manyata starts with a capital M or a small m. Just go in the data set. Make sure it starts with small m because it might start with capital M. And if you use small m, it will not find it because there is no maybe word. Okay. Okay, so now it's working. Somebody's saying it's now working. So if things are now working, use dplyr. Somebody is asking for the R tools. I said if they tell you to install R tools and they say it's not there, come to your script up somewhere. You can scroll up where there are the install lines, the very first lines. Right there, installs dot packages, R tools. Put the R tools. This is how you install it. Run this line so that you can install. When it's successful, then redo. If you are installing this and it failed because there's no R tools, then first install it using install.packages, then go back and install what failed to install. Somebody's saying, are we replying in the chat? No. Submit the Google form, click submit. Okay. Yes. Yes, that is the right question. Number 3. Okay. So if you don't complete the assignment now, you are going to continue later and also do the submission. So you submit the assignment. Just make sure you submit it before midnight, especially before tomorrow's session. It will help. Somebody saying post the assignment, please. Okay. Assignment is there. Maybe I'll also put the link to the assignment in the drive, but it's there. If you go to your Google Drive, in the PowerPoint presentations, the last slide contains, I think, the assignment activity. It's called activity. You'll find it there. Okay. You masked some columns. I don't know what this means. Okay, no, you submit by submitting the Google form. You can use Manyata A. Some people will use Manyata B. We will have both answers. Okay. Please access the Google Drive. I see that dplyr is now working. Reply, please, when you submit the assignment, just submit it in the Google form because we want to receive that form with answers. We want to receive that form with answers. Okay. Okay, we have one instruction. Well, the instruction is submit the form. Click on submit and submit the form. You can do this. You can continue doing this. You can submit the form later. Yes. You can submit the form later. Yes. Just make sure you submit it before we go for tomorrow's session. Okay. Now, when you open the form, Samuel, at the end of the form, click submit. It will come. We will receive it on the drive. Don't put your results on the drive. Open the form, type your answers in, click submit, and we will receive it. Okay, I see that now Tidyverse, dplyr is now working, and we are now having responses. So this is good. Okay, where is the form for submission? We are continuing to put the form here. Maybe also in the Google Drive, I will categorically add the form alone for the activity. Just then you can be able to access it. So ensure if you need to go through later, please continue to look through. This DF, I think let's leave the DF alone for now. That DF requires you to have stable internet. So just leave the DF alone and work with the data set that we have, the animal data, the Kisumu data. Yes, James is saying now that dplyr is working, can you click the filter process? Okay, the filter, first of all, run the lines on filter. I want to believe you have opened the script that we are using. So run it, let me know if you are succeeding, first of all. Let me know if you are succeeding. If you put the cursor there. I mean, if you want to resubmit and you made a mistake, try and do that again. Okay, I did not get Kisumu 3. You don't need to worry. Work with Kisumu main vendor and animal data now. Okay. All right. So, thank you for submitting the assignment. It's now 4 p.m. East African time, and we are going to proceed with the last part of this training today. And we are going to start, we are going to continue from where we stopped. Okay. So we have seen how to select rows. If you haven't completed that assignment, you can do it later and submit it before tomorrow. We have seen how to select rows, how to select columns. Okay, we are also going to look at some other things, like how to create new variables. How to create new variables. Okay. How do we create new variables? Sometimes we want to do a bit of manipulation on the data that we have. And so there is a function that is specific for such things. How do you create a new variable, even if it's basing on an existing variable? What function adds it on to the existing data set? So that one is the mutate function. So the mutate function will create a new variable and add it on the existing data set. For example, if I want to create a new variable called new age by squaring the original variable age, then I have to specify the mutate function so that it can add the new age variable onto the existing variable by squaring the original variable. So when you're using the mutate and you're creating a new variable, make sure you know the existing variable, because what I want is to square the age, for example, and not change the original age, but to create a new variable that contains the square of that age. So how do you do it? In the mutate function, you specify the data frame. Again, because there are many, and create the new variable called new underscore age by squaring the existing age. Okay? So when you run this, even before we run it, in the animal data, look at the animal data here. The very last variable, meanwhile, you can scroll through. So you see these two arrows here, they will take you to the very last variable. So the very last variables are, maybe it's the year. Yes, so the last variable in this data set is the year, okay? Now, I want to create a new variable that squares the age. So when I run this line of code here, it will create a data set called the new age, because that's the name of the data set. Even before we open this data set, you see that it has 147 variables. But the original data set, which is the animal data, has 146. It means there is a new variable that has been created. And that new variable is the reason why we have an extra variable, the 147th variable in the new age dataset. Okay, so when you go to the new age dataset, you should be able to see that variable, and it's usually the last variable. And we can just jump to the last variables here and scroll to see it. Okay, so it's right here. And it actually squares the variables, the original age variable. If you look at the original age variable, for example, it has 4. You saw the other side, it has 16. We can also bring that variable near here so you can have a quick comparison. But now just make sure that you are able to see that new age variable when you actually create it. We'll pause to confirm. You can also take the log of age. We are going to see this because some of these transformations will be useful when we are doing analysis and data science. So it's important that you know how to do them. So now I want to create the log of age, okay? So the variable I'm creating is called log of age, and it is actually the log of age. So the function that will compute it is the log of age. So we run, and my log of age data, this one also has 147 variables because I have created a new variable here. And if I want to see it, I come right here and then I see the log of age created. So this is how we add new variables. We will be doing manipulations because sometimes you might want to run an analysis on the log of the existing variable on the square. You remember transformation. When we reach data science, we shall see that transformation sometimes is necessary before we do run models, before we do analysis. So it's important that you know how to do that at this point when you're managing the data, because managing data also includes creating new variables that will be useful for analysis. So we pause to make sure that your mutate function is working. Your mutate function is working. And mutate will only work when either tidyverse or dplyr is working. As usual, you can say yes when it works. Collins, it's not working. Why is it not working? What error is it giving? You can tell us the error. I'm not able to see what I did in the console. Is the console too small? Adjust the console up and down by putting your cursor here and moving it like this, so you can see what's going on down there in your console. Okay. Okay, so it looks like it's working for people. My animal data has only 6 variables. I think you rewrote the animal variables data. Somebody did not understand how we chose columns. You choose columns by selecting the name of the column. By selecting the name of the column. The number of observations did not change. No, it's not supposed to change. It's not supposed to change. And it works. You can see it, but you need to scroll up to the very end. Somebody's saying it doesn't appear. Now, can you type the number of variables that you are seeing? For you to say it doesn't appear. So if you have 147 variables, it means it's appearing. The only thing is you might not be seeing it. You might not be seeing it. So for those who have successfully run and are saying they can't see the variable, come to the data set itself, like the log age, new age. Okay. Now, when you scroll at the end after opening, you will definitely not see it because you are it's just showing you mine shows 1 to 13. No, yes, but also 1 to 50 columns. So use this one here, these arrows here, to go to the very end, the last page of display. Okay, when you click there, and now we are on column 98 to 147. So you should be able to see the last column, 147. But if you're seeing 1 to 50, it means you're scrolling only the first 50 columns. So for you to scroll up to the end, you need to come down and look at it. You will find it there. If it is successful, it is there. You just need to be able to view and see it. Okay? You just need to be able to view and see it. Somebody says they can see it now. They can see it now. Yes. Okay. That's great. So that's perfect. Looks like we are able to run the mutate function. So there are many things you can do with mutate. Okay. We have another variable here, rather another function called rename that can change the name of the column. Okay. We'll look at 2 and then we will move down to something different. So rename helps us to rename our columns in case you really want to rename a column. For example, I'm looking at the Kisumu 1 data. I mean, you can use any data set. The Kisumu 1 data has a region, a variable called region. I want to change the name of the region to location. How do I change it? Okay. How do I change it? So we change it using the rename function. So in the rename function, specify the data frame that you want. If you don't have Kisumu, for example, 1, use the Kisumu vendor data instead of this one. So the new name is location, and the location will become the region because the region exists and you want to change it. So it's like renaming from region to location. If you do it the other way around, it would certainly not work. So when we run this, the data that has been created 7 now has location instead of region. So it's important that you are able to get that. So that's how rename works. So rename is pretty simple. And the last one we are looking at today is the relocate function. Relocate function. And what does it do? It changes the order in the original data set. For example, if I have a data set that has county, region, sub-county in this order, I don't know, it may be important for you to want to bring country at the beginning, to bring sub-county at the beginning, whatever order it is that you want. I want to start with the slum, the ward, and the sub-county. Clearly right now, for example, the Kisumu 1 dataset starts with time, end time, survey date, okay? But if I use the relocate function, it changes the order in which the columns appear, but does not change the data. So if you ever want to do that, for whichever reason, you can see that the data starts with slum, ward, sub-county. Then it brings every other thing, okay? So it's important that you can run this, you can be able to successfully change names, and also important that you can be able to successfully reorder columns if you need to. So these are common things that we do in data management. These are very common things that we do in data management. And it's important that you have some skills to deal with this kind of information, to manage this kind of data. Now, we've looked at how to manage data. We've seen a few important things. Now, I want us to go into a data set and see if there's missing data, see if you can see if there are outliers in the data set. It's also something very important, a skill that you need to have. Now, I want you to pay attention, especially here, okay? In your Google Drive, and I will go there, I added another script, this one here. So we have day 1 data management with R. We have day 1 and day 2 data management with R. This one here has the code that we are going to look at now. So I would request, if you hadn't yet downloaded, those who downloaded today probably already have it. But if you have not yet downloaded this day 1, day 2, please come here and download it from here. Okay? Download it and put it in your folder. Put it in your folder, and then we shall come to R and we're going to open it up. And how are we going to open it up? And we'll give ourselves time. You come to File, Open, like we did yesterday. Go to File, Open, and look for it if you have downloaded it. If it's on, I don't know, in your downloads, you're going to still find it there. Wherever you find it, just open it. Okay. And I'm going to pause because I want you to open it. It probably has the same scripts, but below here, you will come to somewhere here where there is data summary. And we will start from here because I want to introduce how you can do a summary quickly and how you can check for outliers in your data set. Okay? So we are now in data summary and missingness, and I am pausing to confirm that you have seen that somebody doesn't have the Google Drive. Okay, let's put the link again there. If you don't have it, where's my link? So right now I'm sharing the link to the drive again. So I see that people have got it. People are confirming that they've seen it. And the link to the drive is here. Okay, we are going to export data, but I don't want to export your data now because I need you to first be able to run other things. You can always export the data last. You can export it last. So if you have succeeded, I see that we are done, that's great. And yes, so I want to talk about some few things here. We've done the inspection of the data. We have, you see the distribution of the data. Okay, we are done. We will create the variables after this again. So continue to confirm if you have opened up the day 1, day 2, because that is where we are going to do the summaries from. Okay, this is great. I see that we are done. Yes, please continue to do that. Continue to do that. Okay, that's great. So we are able to access that. So that's perfect. Now, please pay attention here on, I am going to go to this mode here so we can see. Okay, so we are going to look at data summary and missingness because when you are exploring your data, it's important that you know how much of the data is missing, you know how to summarize the variables, those that are categorical plus those that are numerical, okay? So categorical data in particular will be summarized using frequency distribution tables. We shall see. We just need to be able to tabulate to see the different categories that exist in the variables. That is important. And we are going to use the table function. Okay, we're going to use the table function. We can also detect if information is missing using that table function. And then we are going to check to see missingness, but also to summarize numerical variables using the summary function. So these are the two important functions that help us to summarize data. And we're going to do that now in R, okay? To make it so we can see. So if you're seeing my screen now, we are in day-to data management, and we are looking at summaries. So what is a distribution, for example? We want to know how many regions are in the data set. A frequency distribution table is used to group or to summarize categorical data, okay? Not necessarily numerical data. So in the Kisumu main data set, this one here, we have region, we have country, we have county, we have sub-county, ward, slum. So if we want to have a small table that summarizes how many regions, countries, county, are inside this data, then we use the table function. And how does the table function work? Now, the table function references the variable that you're interested in, starting from the name of the dataset where it belongs. For example, this line will summarize how many regions are in this dataset. But you need to specify the name of the data frame, again, because there are many here. And after that, you use the $ to refer to the variable inside there, okay? So if we run the table here, we see the result down here. So when you're doing your work quickly, you probably want to see some of these things. For example, now, there's only one region in the data set. So meaning every information that's there is coming from East Africa. There is a variable called the consent. You want to know how many people consented. Do we have anyone that didn't consent? Sometimes it's a data entry error, okay? So let's check. 1 means yes. Looks like everybody consented because we have only one outcome. Then how many counties are included in this study? Okay, can we run a simple table of that? It's one county, Kisumu. I'll pause just to see if your table is working. How many sub-counties are there? Let's take a frequency distribution of the sub-county itself. We can have, okay, we have 2 sub-counties. We have Kisumu Central and Kisumu East. Now, if you want to have a vertical arrangement of these results, okay, you can also do that. How many words are there? We have 3 words. We have Manyata, we have railways, we have Kondele. Now, you can transform this table function. If you transform the table function, this is what you get. The same information, but arranged vertically like this. So you can have the frequency on one side, and you can have the variable and the different, this is a word. We are looking at the tabulation of the word, right? So you can have the different words here. And then we also went to the animal data set to see if we can tabulate, get a feel of how many breeds are there. And so we were able to find that we have the local breed and the improved breed. How many in each category? We can be able to determine that when you do a tabulation. Then for the species of the animals, we are also able to run and see. We have bovine, we have goat kid, we have lamb, and how many are in each category. And it's important now that after all that, you can summarize your data in the shortest time using the fastest way possible if you're looking through your data. And these functions are base R, so they will not probably need libraries. So I'm pausing here just to know if your table function is working. Run the table function. Yes, it looks like a pivot function in Excel. Yes, it's doing the same thing. Working, please confirm, working, successful, done. So it becomes easier when now you have things arranged and you have a table, run them. Are you able to see them? Are you able to see them? Yes or no? Somebody has an error. What is your error? How did you get to that table function? I hope you are in day 1, day 2 data management, which I loaded, and now it has this. So yes, if you can copy one of the outcomes from down and paste it on the chat, that would be good. My day 1 data 2 management is not opening. Go to File and go to Open File. When you go to Open File, look for it. If it is in the download, search for it. If it's in data management, look for it. It is an R file. It looks exactly like this. Day 1, day 2, click on it. You will be able to open it. Okay? And open, it will come. Okay? So I see that people are getting results. I repeat the process. Which process am I repeating? Is it the one for accessing day 1, day 2? If it is the one, then come to File and Open File. Then look for it and open. Look for it and open. Oh, the data summary. Is that the file? Are you talking of the PowerPoint? Maybe. Okay, I'm not sure if are you referring to the PowerPoint? If you're referring to the PowerPoint, it is not yet uploaded. If it is the current step we are at, we are in data summary. We are on item number 10. Okay, somebody is saying the animal data. There's a file there that has something to do with animal data. Okay, the current step where we are here in data summary frequency tables. I want you to run these one by one. I want you to run these and see the tables, make sure they're working. See that you can summarize county, sub-county, ward, and I see that many of us are succeeding. So it's important that you are succeeding together with the rest of us, okay? All right, now that we are succeeding, we will pause again for questions. We go back here. So there's something that we haven't looked at. We continue in the summary. Let's summarize the word and see. We are proceeding to run the next line. We are doing a summary of the word. Okay, a summary of the age. Meanwhile, when you do a summary of a numerical variable, you get the minimum value, the first quartile, the median value, the mean, the third quartile, the maximum age, including missing values. So we have 5 values that are missing in the age, so you can be able to get it. So that's how you can get age. You can also do a tabulation of what is missing in the age using the is.na function, for example, for animal age. If you run that, okay, so it is true for 5, meaning 5 animals are missing edges, or 5 sets of rows are missing the edge. If you want to do that, maybe for the word, how many are missing in the word, you can also do the same. False, it means we have none. So where it is true, it will capture the number that is missing. Where it is false, it will not be able to capture the number that is missing. So that is how you find missing values in the data sets that we have. And we will pause for you to let us know if you are able to run the table. Can I summarize in more than one criteria? Yes. Can I summarize in more than one criteria? Yes, that's very possible. And continue to confirm if you're successful in that. Once your R is working, it becomes very easy. Yes, you're going to have the recorded version. Okay, if it's true, it means it's missing. If it is true, it means it's missing. Okay, I see done, successful. Okay. Somebody's saying their script of day 1, day 2 is still showing the same. Yes, it will show the same up to the end, and then day 2 has more information right below. So just scroll down to item number 10, then you start from there. False means it is not missing. Okay, false means it is not missing. False means it is not missing. Okay. Okay, so we are on the right track. Okay, so now we are going to look at a few more things. I'll go back to my slideshows and move to something else. And that is the distribution of data. So it is important that you understand the distribution of the data that you're going to deal with, because it dictates a lot on the statistical tests that we are going to choose to use to analyze our data. Distribution of the data. Understanding the distribution is key for numeric data. Mainly, we shall be looking at the distribution of numeric data, checking whether it is normally distributed or whether it is not normally distributed, so that we can see whether we want to transform data or whether we want to choose non-parametric approaches to analysis when we reach that stage. Okay, so how can you assess the distribution of a numeric data that you're interested in? There could be many, but what are you interested in? Do you want to, for example, if it's age, what is the distribution? How can you determine if it's normally distributed? How can you determine if it's not normally distributed? Remember, I said it's important to know the distribution because it helps you to choose the right statistical methods, the right statistical tests. We have tests that we use when data is normally distributed. We have tests that we use when data is not normally distributed. So there are 2 ways. We have the visual approach, which we usually do using the histogram, but we also have a statistical test of normality called the Shapiro-Wilks test. This test helps us to determine clearly if data is normally distributed or not normally distributed. And we are going to do both. So before we run that test, let's explain what happens when you're checking for normality or when you're checking for a distribution of a data. You can draw a histogram, which we usually want to sort of see if it has a bell shape, if it has a tail, etc. And quickly, you can use the hist function to find the histogram and then perform the test to see if the data is actually normally distributed. The test that we are using is called the Shapiro's test. Shapiro's test checks whether the variable is normally distributed. And how do you interpret the results of Shapiro's test? When you look at the p-value here, you can quickly determine if the data that you're looking at is normally distributed or it is not normally distributed. So if the p-value is small, you can see whether it is distributed or whether it's not normally distributed. So we're going to demonstrate this in R. Again, everything we are doing, you need to be able to quickly run through it practically and see that if you're dealing with your own data set, you can quickly check if the variable is normally distributed or not. And we are going to do that just now. In R, okay, let's look at the distribution of age. We start here on data distributions using the visual approach and the statistical test. The histogram, we're going to run the first histogram on the age. Remember again that histograms are run and used to visualize numerical data, okay? So let's check the distribution of age. Let's check the distribution of milk yield. This variable also exists in the animal data. So if you run this, make sure you can see the plots are on this side. Down here, you can expand, you can zoom, okay? So you can be able to see your age. This histogram here is clearly not normally distributed. It has a tail on the right. Let's see the histogram for the milk yield as well. And if you zoom, you can click on zoom here. And yes, it is clearly not normally distributed because it has a tail here. But you are going to perform the test so you confirm. But before I proceed, let me know in the chat if the histogram is visible on your side. Histogram. Somebody's asking, what does the outlier do? We are going to do outliers. We have not reached there. Is the histogram visible? Yes, yes, you can type 1. Somebody's saying the margins. The person who is seeing margins are too small. Look at my screen. Expand this part here. Okay, expand it, then run the code. Like expand it so it's big enough to contain a diagram. Expand it, negatively skewed, yes. So I see that we are getting the histogram. Yes, we can edit the axis. We shall see how to do that in detail, most probably when we move into data science. Okay, somebody can see it now. Yes, so if you are not able to see it when the margins are small, expand the place where it's supposed to appear so you can be able to see it. So now it is working, and please continue to confirm on the chat that you can see your histogram. Okay, and that is great. Error in the plot, figure margins. So Eric, if you're getting this error, look at my screen again. Please expand this part here. Expand it on both sides so that when you are running that code, the figure fits. So it's not fitting inside this part here where it's supposed to be. That is why it's saying the margins. Okay, great. So people are able to see that. So that's perfect. Somebody's asking about outliers. We are going to look at them. So the histogram, of course, shows that data is not normally distributed, but we need to perform the test to be very sure, okay? So the Shapiro's test, again, we are going to run it on the edge, for example. Okay, when you run the test, it comes with a p-value. It comes with a p-value, and it's important that you can interpret the p-value very well. When the p-value is small like this, that means it is less than 0.05. It means we reject the null hypothesis, and the interpretation is that age is not normally distributed. When the p-value is significant, age is not normally distributed because we reject the null hypothesis. Now, let's run the test on the milk yield and see if it is normally distributed. In the chat, tell us whether it is not normally distributed. Is it normally distributed? Yes or no? Yes, no. Is it normally distributed? Yeah, no, no. Meanwhile, what you think is the right answer is what you write. Okay. It is not normally distributed. We have, okay, great. So we are able to interpret this correctly. So it's important that you can quickly run through your data, perform the test, so you can see if your data is not normally distributed. It is a very important step in preparing to choose the right statistical tests when we come to that part. People usually use wrong statistical tests and wrong models to run and get results, make decisions basing on models that were not appropriate for the data that was used to run the model because the distribution was got wrong. So it's important that you know how to understand and do the distribution of that data set. Another important thing that you need to deal with, which is probably the last thing we are seeing, is outlier detection. Outliers tend to exist a lot in our data sets. They help us understand how the data was collected. They help us understand the magnitude of the data that is usable within the data set. And it's important that you know how to detect outliers and what their implication is in a data set. Okay, so because outliers can drastically affect our models and hence our results, it's therefore important that you're able to see if a variable has outliers and possibly compute the outliers and see how to deal with them, which we shall see. Now, outliers are quickly detected. Remember also outliers are mainly appearing in numerical data, okay? So it's important that you understand if a variable has outliers before you plug it into a model, before you use it for prediction, okay? Sometimes this out of range data could be an issue of data collection. Maybe there was an error in the measurement. It's important that you check them out. So when you receive data, you don't just plug it in. You need to explore, understand the quantity of missingness. You need to understand, especially these outliers, you need to take care of them. So usually when we are looking out for outliers, we use box plots. Now, visualizations are good because they help you to quickly understand what's happening in your data. When you have thousands and thousands of rows of information, it's important that one visualization helps you to quickly understand any problems that exist in the data. Then you can go inside and do computations to extract those issues that you need to deal with. You need simple ways using visualizations. And the simplest way is to use the box plot in our case. So a box plot contains lines. It has the median, it has percentiles, it shows you the minimum values, the maximum values, together with the outliers that exist in your data set. So typically, a box plot looks like this. Whatever points you see outside this maximum line will be an outlier in your data set, okay? So when you're looking out for outliers and you draw a box plot, you are looking out for points that go beyond the maximum. I mean, they will not be labeled like this when you actually run them, but it's important that you understand what the box plot shows. Now, also, the box plot has the median of that variable here, okay? It has the first quartile. It has the third quartile at the tip of the box itself. Then it has the maximum and the minimum, okay? Our interest when we are looking for outliers is to see where quickly, if there are any points, and then we can go into the data set and begin to extract them, look at them. You quickly realize that these outliers are probably inflated values that got changed when they were merging, values that might require you to actually go back to the source of the data, verify and correct it, okay? So how do we check for outliers? We are going to demonstrate it in R, like somebody said. Let's look at the edge. We are here. The box plots are on this line here, outlier detection, and see if the edge has any outliers that we need to be worried about. Now, the edge is from the animal data, and we are using this basically because box plots generally show us distribution, but also outliers within numerical data. Then we run. Meanwhile, if you cannot see yours very well, you need to expand or to even zoom. Well, my zoom doesn't look very nice, but okay. Now, if you can see, we have quite number of outliers in this data. So quickly, now you know that you have some outliers, which you can eventually go in and get. That is how you detect outliers. The median edge is somewhere here. The minimum edge is somewhere here. The maximum edge is somewhere here. The first quartile of the edge is somewhere here. The third quartile is here. And remember, we got that information when we ran the summary function. The summary function actually brings them here. And then the box plot helps you to see that. So run your box plot. Let's see if you're successful. But I also want you to run the box plot for the milk, the dam milk, this one here. So let's get the box plot for from the animal data, and I will pause after that so you can tell me. So here you can start by typing the dam what is it called? Milk yield. Then it will come, then you can choose it. I want you to run the box plot for this particular dam milk data. And after that, I want you to tell me if there are any outliers in the milk yield. If there are any outliers in the milk yield. In the chart, confirm, first run it, look at your box plot. If you see points that are beyond the maximum or below the minimum, because the outliers can be below, this one, the edge doesn't have outliers down below the minimum, but it has outliers above the maximum. So run the box plot on milk yield, and in the chat, let me know if milk yield has outliers, because this is a very important variable in this data set here. Usually they're interested to know the milk yield from the different animals, especially somebody saying yes. You can count them if you can. Does it have? Yes. I see that it has about 8. Okay. If somebody doesn't have them, that might be a challenge. Somebody has 5. Let's count them again. Somebody has 12. Okay. Don't be pressured by people's answers. Just count yours and put them right here. Okay. We are doing well. We are doing well. How we remove them from the box. You want to remove them from the box? Yes, we can compute them, but we don't remove them from the box. But we can now determine what they are. Okay, just make sure you're able to see them. Okay, so it's important that you are able to know quickly whether you have these outliers. Okay, if there are no outliers, does it mean the data is normally distributed? No. Normally distributed data can have outliers. It doesn't necessarily mean that if we don't, we cannot. Somebody's saying, how do we save our data? And that's the last thing I'm going to do. The data is saved. You see this information in your environment. When you come to close it, it will ask you to save your workspace and you will save it. Okay? Now, but for example, the things that we've done here remain in R. They are not in your folder. And that is because they are in the R environment. So it also means that, for example, if you created a data set that has male, right now it is in the R environment. So the real question is, how do I export it outside so that I can share it with, for example, if somebody made a request that I want information about the males only, okay? And they don't have R to do that. And now you are the one who has extracted them. Or how give me the data set that has male vendors from Obunga only. That's the only thing I need. I don't want the entire data set. And you come to R and you do what we've done today. You have all these data sets here. How do you write it out? How do you export it out? For example, take it to your folder so that from there you have the Excel sheets. Because by the way, whatever is in R right now remains in R. Every manipulation that you've done remains in R. So if you want to do that exportation, then you use what we call the write function. The write function exports the data that you have here out of R, especially if you have created those data sets that you want to share in a certain platform that have been requested for. You need to know how to remove it from here and take it to your folder. And we are going to see that as the last thing, because it's important that you know how to take your data out of the software. So we use the write functions. Now let's together, we are going to scroll up. I skipped that because intentionally I wanted us to be able to do all the manipulations and then write it after. So we are here now in exporting data out of R. So go right there. Let's explain how you export data out of R. One, you need to know the function that does that. And just like when you're reading data, the functions that read the data are specific to the data files that are being read. So even here, it is very specific. If you want to export to a CSV file, the function is write_CSV. If you want to export an Excel file, the function is write_Excel. If you're exporting a stata file, it's DTA. We know that the file extension is this. This file extension is for SPSS. This one is for SAS, okay? This is not the file extension for SAS, but this is the function that exports out into SAS. And write.table exports to a text file. Now, we are interested in running this to see if it works. So let's start with the CSV file, but make sure you give it a name that when it goes to the folder, you will find it with the name you have given with the correct file extension. If you don't give the correct file extension, it will not create a CSV file. So if you want it to create a CSV file, you must call it CSV. And the data that you're moving out from here should also be specified. In other words, this code will write the log age data from R into a CSV file in your folder and call it log age. I usually use the same name. The same name of the data here is the same name that we are taking there because we've created something new. So let's run and see if we can export the first file, which is a CSV file. That one has been exported. The mail has also been exported. And how do I know it is exported? There is no error here. And when I go to my desktop, in my data management folder, if I should find that file here. The mail file is here. It is an Excel sheet, right? Because I specified it. And this is the time when it was exported, and that's not the time now. So it has gone. So now you can share the mail data as an Excel sheet. Now the log age, on the other hand, is CSV. So you can see that the file type is CSV, and it has been successfully exported out of R. Okay, so you can export out of R using the write function. And then let me try and export data 4, but I want to export it as a data file. Okay, I know it has gone. The Obunga mail data, which we also did at some point, I want to export it as an SPSS file. Hopefully it worked. Now this one has an error. And then I want to export the SAS file. And maybe we shall also export the text file. I'm more interested in the CSV and the Excel. Now, when I go to my folder on the desktop, I want to see where, for example, the Obunga data is. Is it a SAS file? Yes. Meanwhile, I said earlier, you don't need to have SAS in order to export it. Okay. So I'm going to pause, and I am pausing because I want to know if you have successfully exported the CSV file and the Excel file out of R. Did you successfully export? Did you write CSV out of R? That is how we export. And the Excel file, CSV and Excel. Somebody says not successful. Somebody says yes. Somebody says yes. Somebody has exported both. The DF may not work because some people fail to CSV not found, right _ CSV not found. Especially those who fail to install Tidyverse may have challenges with writing the CSV, but we shall address that. Somebody's asking what's the difference between, let me see.
Please, they can install readr. We'll do that.
readr? Oh,
yeah.
Okay. All right, so some are successful. Okay. Okay. If you're failing to install, right now I am interested in importing data is bringing it into R, and exporting is taking it out of R. We want you to be successful in both. Now, lastly, if you're failing to export a CSV file, I'm going to address that quickly. That means your Tidyverse did not work. That means your Tidyverse did not work. If your Tidyverse refused to work and you use dplyr, now I don't have it here, but if you use dplyr, you also need to install the package of, it's called readr. Okay, now this package here will help you to export CSV if you're failing to use Tidyverse. Because when you install Tidyverse, it installs even readr. But when you fail to install Tidyverse, then you have to install this one alone. And when you install it, it should succeed. It's like dplyr, the way we did for dplyr alone. You also run the library for readr, then you should export out of R into your folder. Make sure that in your folder, you are able to see the things that you've exported, especially those files. It's not, it will, okay, somebody has exported, it will be important. Okay, so verify that you can actually export your data out of R. It's important. Confirm for me. Okay. Somebody wants to find out if there's another training. If there's another training, we shall announce it. For this one, it's building on yesterday, today, tomorrow until Friday. Then after that, we will announce if there are other trainings, and then you can. So if serve is not working, we'll find out why. For now, you should be able to export Excel and CSV, which is important. Okay, somebody doesn't see attendance. We can actually tell you attendance without you having to fill in any form. So right now, it is 2 minutes to the top of the hour, and I would like to end this webinar here and hand over to David. Thank you so much.
Thank you very much, Peace, for the good job. I think participants have enjoyed the training. From our side, we don't have any comments really. I think maybe at this point, if Dr. Opio has something to say or an announcement or a comment, maybe he can do so, then we close.
Thank you very much, David. First of all, I thank the participants. I think our training is going well, and I think I don't have much to say, but I think tomorrow we'll move to, after finishing R, we'll go to QJS. Thank you. Back to you.
Thank you so much, Steven. So participants, let's close for now. The interactions continue on the WhatsApp group. Please keep following and also access the recording which has already been shared. You'll find the link on the WhatsApp. Thank you very much.